you may inspire the next Gerhard Kuska. You might be the next Gerhard Kuska. All of those things are possible. This is truly an amazing place filled with amazing people, of which you are some. So anyhow, another one of our ocean heroes from right here at the Monterey Bay Aquarium. So enough storytelling. I am delighted to introduce Tracy Reid, who is kind of the queen of storytellers here at the aquarium. I've had the pleasure of working with Tracy in a variety of capacities. My timing isn't very good with this, but Tracy is here to talk about mollusks. But back to Tracy. I think most of you have seen Tracy here at work in the auditorium or doing different presentations. You may have seen her underwater here at the aquarium. She often appears in the kelp forest on Wednesday afternoons as our diver, feeding the fish and interacting with the guide on the dry side. And we've had the opportunity to work with Tracy actually as a trainer here at the aquarium for the past year or so. And so now she's on to a few other things, but wanted to take an evening to share some fun stories about mollusks with all of us. So, and I can't think of a better topic to fit Tracy's style, because there's a lot of really cool stories about mollusks, which you are about to discover thanks to Tracy Reid. So thank you, Tracy.
Thank you. All right, here we go. And it's sort of funny because my story is sort of like opposite of Gerhardt's. So I was working here for about 10 years, and I decided to go the other way, which is to explore sort of other avenues and sort of find out where else life can lead me. So the good news about that is I am a volunteer now, like all of you. And the good news about that for me is that I have always wanted to think, if this doesn't go well, what are they going to do? Fire me? They can't. I'm a volunteer. All right, so let's talk mollusks. Let's hope this goes well. Mollusks, so let's just start. Just shout it out. When you hear mollusks, what do you think? Shout it out. Clam, squid, snail, slime. What else? Octopus. Yeah, so we all have this general idea, and that's the first thing that comes to your head, and that's likely some of the first things that come to our guest's head, too. So even though the term mollusk is this nice, big, sort of sophisticated term, always remember that when you're interpreting, you start by meeting the person where they are and what they know about when it comes to mollusks. And mostly what you all named is kind of what comes to mind, so commonly referred to as snails, slugs, clams, I heard that one. I heard octopus. I heard about slime. And of course, the big one, dinner. Yes, a lot of us, or a lot of people, their experience with the world of mollusks ends up being on their dinner plate. So we'll be talking about that a little bit too. Now, one of the more difficult things about mollusks, though, is how huge and how diverse this group of animals is. So we're going to talk generalities. I'm going to try and go into some specifics in some different areas, but it is such a large topic that any one of these classes of these animals we could spend an entire session on. So I'm going to try and see how much we can fit in an hour. Mollusk, the term, means literally soft-bodied, and so that is good to know. And there are a lot of them. There are somewhere between 100 to 120,000 mollusks out there, which makes it actually the second largest animal phyla after those arthropods, which was what Lisa was talking about. However, I do want to put this in perspective. It is the largest marine phyla because those arthropods, as she was talking about, include lots of insects. So when it comes to the oceans, mollusks end up really being the ones that kind of rule the roost there. And then the most kind of impressive thing is this incredible variation in terms of their body plan. So really, you can't make a whole lot of generalities in terms of every mollusk has this or every mollusk has that because they are so varied. But that's also what makes them an incredibly fun phyla. So just looking at that kind of a little more, she showed a pie chart of showing how much arthropods in terms of all animal phyla, but specifically with marine phyla, you can see that mollusks at 23% are giving crustaceans a run for their money. So crustaceans, there's usually around 80,000 or so. So mollusks win! Okay, the other thing that she showed, which I really liked and wanted to reference, and I also believe George will be referencing this when he talks about jellies and cnidarians and things like that, is sort of evolutionarily how we are looking and where the mollusks sort of fit. So I like this because it's really basic. It's overly simplified, and so if you are an expert in taxonomy, I apologize, but I'm going to make it even more sort of super simplified. This kind of appeals to sort of the way I think organizationally. So when you start to look at mollusks, basically what you have gone over, what we've been doing with this class, is kind of going from the top down. So you've talked about marine mammals, you've talked about fish, you've then gone into some of these arthropods. So we're kind of working our way down the evolutionary chart. But if you kind of go the other way, when you think evolutionarily, what we're doing really is getting more and more complex. And like Jim said, we're sort of in the middle of class. Well, mollusks kind of start to be sort of in the middle of sort of evolutionarily how we start to get a little more complex. And I think this is important because what this means is we're going to start at this point getting into the animals that are a lot less familiar. And the animals where you look at that thing and you say, or the guests say, that's an animal? Where is its fill in the blank? So this is kind of where we are. So if you kind of look at it this way, and this is really, really general, going from this side, evolutionarily very simple, we're at around 545 million years as mollusks start to develop. Okay. So, and this is also a big theme of the class, is each one of these phyla have started to develop in such a way that they have done something different from the phyla before them or from another class of animal. So how did mollusks conquer the world? So what we are essentially looking at are three questions that animals or organisms ask of themselves or have to figure out. One, I need to get food. Two, I need to avoid becoming food. And three, I need to pass on my genes in order to be biologically successful. So what exactly have the mollusks done in these three categories in order to kind of be successful? First, advances in mouth parts to get food. So Lisa talked a whole lot about the crustaceans having lots of different mouth parts. Take this kind of back a step. Before that sort of explosion of mouth parts in the crustaceans, mollusks were starting to develop what's called a radula. And we'll talk a little bit more about the radula. And just so you know, let's see, here it goes. Radulas are unique to mollusks, but not all mollusks have radulas. So however that works in the Venn diagram. Radulas, however, are very important to the mollusk family, or mollusk phyla. Another thing that mollusks did, nice, strong, muscular foot, and then they use that to get around. So the presence of a muscular foot is another way that mollusks conquered the world. And then a lot of really interesting advances in circulation and in the nervous system. So those things all led to the possibility of being able to get food. In terms of avoiding becoming food, the big one is finding new ways to protect a soft body. How do we mostly think of mollusks when we think about that protection? Shells, of course. And a huge number of mollusks have shells, but not all mollusks have shells. And as a matter of fact, there's a great big theme in terms of reduction of shells or how the shells have been modified. So, but they have all found ways, new ways to protect their soft body. And then passing on genes, super diverse in terms of reproductive development. So they kind of run the gamut. And so they go from the very simple, which is essentially broadcast spawning, which is where egg and sperm go out there in the water and everyone hopes for the best, to much more complex. You're starting to see reproductive organs. You're seeing, Jim, you're seeing what we just discovered, which is a type of nudibranch who has a penis, and then it pops off, and he grows a new one, right? Is that how it works? Something like that. Anyway, so those are awesome developments. Now, and that's just one of many. I'll try and keep it G. Do I have to be G or PG or? I'll try and keep it biologically accurate. Okay, so, but with all three of these categories, you have basically with any kinds of developments, you have really consequences. I think of them as pros and cons, but really it's just sort of consequences of development. So for example, when it comes to having more complicated mouth parts like a radula, good thing about that is that you can start to diversify in terms of your diet, or you can start to specialize. The bad part about that is you might not be, not just eat anything, so you might have to be a lot more specific. And that really plays out here at the aquarium. For example, there are some nudibranchs that only eat a very specific type of sponge. And some of them, we don't even know what they eat. So it's very difficult to display them because once they have finished eating the sponge that they came in on, or the rock that they came in on, we don't know what to feed them. So that's a really good example of how that might be a con too, or certainly a consequence. Nervous system. So there are incredible strides in terms of the nervous system all the way kind of throughout the phyla, which is great. That means that things like eyes can become more sophisticated. Things like, the cephalopods can start to do things like change color because they can send messages throughout their body. The difficulty with that, more complicated systems mean more delicate systems. So now you have eyes that you need to figure out how to protect, or other sort of sensory parts that end up becoming much more delicate. In terms of becoming food, an example of one of the things that mollusks have done in terms of getting shells. Shells offer a whole lot of protection, but of course, what else does it do? Slows them down. And so that's, of course, when snails end up getting the reputation of being super slow, which would be kind of a con. And then in terms of passing on the genes, when we talk about all these different genetically, different ways to pass on your genes and being a little more genetically diverse, for example, having male and female. So there, in the mollusk phyla, there are a lot of separate sexes, not all of them. Some of them are hermaphrodites, but there are a lot of separate sexes, which is great. One of the good things about that means you have lots of genetic material that's mixing, so you're going to be a lot more genetically diverse. Bad part, you got to be able to find a mate. So there are always these sort of trade-offs. And so when you think about how the mollusks did, there are definitely consequences to what they developed. All right. So what makes a mollusk exactly? So like I said, they're very diverse, so not a whole lot of very specific things. But this is the basics. One is they have a soft body. Mollusk means soft body. The second big thing is the presence of a mantle. So that's a big one for mollusks. Mantle comes from the term robe or cloak, so it's essentially wrapping around the animal. And the mantle is what is responsible for producing the shell in mollusks that have shells. That also then allows a presence of a mantle cavity. And so the mantle cavity is essentially where all those inside parts start to grow and get protected by that shell. So a mantle cavity, and then a muscular foot, or some variation of a muscular foot. So in the most basic, as we'll see, some of the chitons and some of the snails, that muscular foot real clear. Gets a little more complicated. For example, octopus, their muscular foot, instead of being a muscular foot, now becomes 8 muscular arms. But the basic is that there is a muscular foot or muscular type of organ that sometimes gets modified. And then the other thing is, we start out in terms of the nervous system. All mollusks have at least 2 nerve cords. That's the most basic. And then it gets very complicated from there, going all the way up to a whole nervous system in the cephalopods, which are the more complicated and more sophisticated mollusks. And so then there's a whole bunch of other stuff that you tend to see in mollusks that may or may not be present in different families and different phyla and different classes. Not limited to, not including, but all of the different things you're seeing here. So that radula, a shell or remnants of a shell, eyes in various levels of sophistication. So some of them just have eye spots, some of them have very sophisticated eyes. Feelers or antenna, slime, as one of you mentioned, a siphon, a brain, Some of them have venom, separate sexes. Some of them have gills, and some of them have lungs, because some of them are air breathers. They are not all marine. And then open and closed circulatory systems. So some of them have blood that essentially is washing over their organs, and some of them have a specific closed circulatory system with vessels and the whole 9 yards. The best way, though, to take a look at the mollusk body plan here. So what scientists tend to do, especially in textbooks then, is they generalize when it comes to the mollusk body plan. And I think that the best thing to look at is, Shape of Life is so good at this because they have fantastic footage. So they have a good video of a basic mollusk body plan based on an abalone. And let's see if this works. Hopefully you'll be able to hear it too.
The basic toolkit of a mollusk is evident in the abalone. Most mollusks have some kind of foot. For many, including the abalone, the foot muscle bestows mobility. When the foot brings them to food, mollusks eat by using a unique rasping tongue called a radula. Covering the vital organs is a fold of skin called the mantle. It's the mantle that secretes the trademark body armor of so many mollusks, the shell.
I love that guy. Okay, so that's just a good sort of overview of a general body plan for a mollusk. But of course, it gets much complicated. Okay. So basically, and that's the kind of more complicated one. And that's sort of a general one. I lost the little pointer thing. Well, eventually it'll show up. Okay. Okay, so the radula, that was mentioned, and we've talked about the radula. It's unique to mollusks, as I said, but not all mollusks necessarily have them. There are some different sort of styles and kinds of mollusks, or of radulas, but essentially think of it as, you can think of it as teeth, denticles. Usually they will do one of two different things. One is they will rake at things. The ones that are raking are the ones that tend to have more pointy denticles, and then the rasping tends to be for getting into more like plant-like material. So it's a great algae scraper, and then hopefully I'll be able to bring up a video of a radula at work. Maybe. Oh, there it goes. So it's just nice to see. When I first heard about a radula, I was a little confused. So I kind of always wanted to be able to see it. So usually it is surrounded by sort of cartilaginous ring, and then it will, the animal will, depending on different kinds of animals, but the animal will put out some sensory parts and determine if it's food, and if it is food, then it'll use that radula to essentially scrape off whatever it can. So, and that's just cute. Isn't that the cutest thing? Okay. Another kind of weird thing about the radula is so there is a mineral called magnetite, and in the radula, this is the only known biological production of that mineral, and it occurs in radulas. That's just nice to know. Okay, so now we're going to go into sort of the different classes of mollusks that are out there, and sort of the general makeup of these different classes. And by the way, on the very top, controversial and in flux. So keep that in mind. Scientists love to argue about things. So there's 8-ish different classes of mollusks. But the main ones that we're going to concern ourselves with are the top 4 that you see up there. I went back and forth. I want to go with more common names than I do scientific names because the guests don't really get scientific names, so it's a lot easier to kind of go with some of the sort of common names. So you've got the chitons as one category. The bivalves, those would be the ones, bivalve meaning 2-shelled, so those are the ones we eat a whole lot of those, so clams, mussels, oysters, that kind of thing, gooey ducks. Gastropods, notice there's 70,000 of them. So they are by far the largest category of mollusk out there. So that's generally what you're going to be running into. Those are the snails, the slugs. Those include land snails as well as marine snails. So that's a huge category. And then finally, the more sophisticated would be the cephalopods, which are your octopus, squid, cuttlefish, nautilus. Those occur in cephalopods. Lots of really amazing variation there. We're not going to spend too much time on the cephalopods for the main reason being that we have a cephalopod exhibit that is going to be developed in, is it 2014? 2014. So you're going to be getting a whole bunch of fantastic cephalopod information over the next year. So that's an incredible category of mollusk. And then the last 4 are a lot smaller. You've got some extinct fossil classes. So the big 4 are the ones you really want to kind of pay attention to, and those are the ones we're going to be kind of looking at. Okay. So we'll start with the chitons. The chitons are polyplacophora or polyplacophora, depending on how you want to pronounce it. I like polyplacophora because that means many plate bearers. So you can remember the chitons by being a type of mollusk that has a whole bunch of plates that work together to create their shell. 8 plates in the chitons are what create that shell. They all have a radula. They are probably the most they represent the more simple body plan when it comes to mollusks. They have a mantle. They have a mantle cavity. And some of them have simple eyes. They're the ones who do pretty basic reproduction, external fertilization. So that would be the broadcast spawning, where you've got males releasing sperm, females releasing eggs, and everyone crossing their fingers and hoping that that all works out. A couple of things to notice here, which this is, so here are the 8 plates on a chiton. Here are what they look like after the animal has died, and you're looking at one of those plates. Actually, I see one volunteer with it. A lot of volunteers actually have a chiton as a pin. I don't even know where those come from, but that's what those are. They are also called butterfly something or another's because they look, what are they called? Butterfly shells, exactly. So you sometimes see those washed up on beaches too. Yeah, and so those are from the bigger chitons, the gumboot chitons, nice and big. The other thing right here is the other side of the chiton. So what you're seeing here is that large foot, a simple rudimentary head here, and then in the case of the chitons, the gills are on both sides of that large muscular foot. I found this picture, which I thought was an interesting one because, and I have to admit to you, I borrowed extensively from the internet for pictures. So I hope that when possible, I use legal pictures. But since you're not getting paid and I'm not getting paid and this is an educational institution, I took some liberties. So I do apologize if you're in image resources, don't use any of these. But what I thought was interesting about this one is the fact that I think this is the Monterey Bay Aquarium, because that sure looks like the touch pool corner there, doesn't it? And the other note on that is, I don't think this is what you're supposed to do when you're at the touch pool. Is that right, volunteers? Yes. So, and this is good to note, which is why I'm showing you this picture, because if you were to do this, you can see that the gills are on the side of the animal, but we don't take the animals out of the water. We leave them in the water. Because even if the animal could handle that for short periods of time, we want to, of course, show excellent practices when it comes to handling animals and being very gentle. So, but that's the underside of that, of the chitin. So here's some examples of chitins that you will see around the aquarium, and I believe one of them, I think it's this one, is one of your stops. This is the gumboot chitin, that nice big chitin, lined chitin here, a little bit smaller, and this is called a carnivorous chitin. And so that's one of your stops, I believe, when we're going around and looking at some different chitins that are around the aquarium. All right. That one's cool, carnivorous chitin, so they don't just eat algae. They also do some other stuff that you'll learn about later. All right. Bivalves. So now we're moving into the clams, the mussels, the oysters, the scallops, the geoducks, anything essentially that has two shells and shuts. Bivalve, meaning two-shelled. And there are about 20,000 different species of bivalves. Most can move. Some don't move. A good example of a non-moving one would be mussels. They tend to not move, but a lot of clams do move, even though you don't see them moving much on your dinner plate. The differences when it comes to the bivalves, just a little bit in terms of the anatomy, is that, so they've essentially shut themselves so that they're protecting themselves by shutting with two halves, with the two shells. So that means everything is inside, and then they use their foot essentially to move, and so they kind of pull themselves along. I don't want to get too complicated there, but simple eyes, a lot of them have. Suspension feeders, so this is one thing that is developing in terms of mollusks, that you'll see some organs get developed and they serve multiple functions. So in the case of bivalves, a lot of times the gills will act not just as a way to breathe, but also they will be ciliated, so they will also be a way to sort of move water in and out. And so that is something that kind of starts to develop with the bivalves. And, of course, there are freshwater clams. There's about 2,000 different kinds of freshwater clams. And that's where you get pearls, too. Oysters make pearls. Okay, so some examples of some bivalves. There on the left, you have got a mussel, which is not a mover, attaching itself with some very strong threads. These are called byssal threads that are just like cement, so that the mollusk is really holding on. And then here you have a rock scallop. I'm not sure if we're visiting. Steve, are they visiting rock scallops tonight? Yeah, I thought you might know. No, okay, yeah. So, you're not visiting rock scallops. And, okay, here's what I like about scallops, is because when I look at a scallop, I'm like, big deal. What's the big deal? So the scallop has got eye spots around here, but they actually move. You just never get to see them move very much, so you will now, which was kind of a nice little short video here on YouTube of a scallop escaping, I believe, a sea star. A scallop who is swimming. I don't know what that's all about. That's it. I just love that. Isn't that great? Let's watch it again. Why not? You just don't think, I mean, it doesn't look like it would do that. And every time I've ever seen a scallop, I'm like, oh, please just sit there. Okay. So there you go. Some of them move. Let us continue on. Oh. Okay, so one more, and I'm showing you the giant clam. You will be visiting the giant clam tonight. Really awesome. It is the largest bivalve. It has, put itself in half, but what's happened is that the mantle, that girdle, has basically fused, which is why on the inside, it pretty much is all fused together. So it doesn't look like just a shut sort of clam. It's a giant clam sort of opened up a little bit with this fused mantle. And you'll see a hole there. But really, the reason I wanted to do this was because I found the most awesome video ever of Batman and Robin being eaten by a giant clam. And so this is the only reason I'm even talking about giant clams is because I want to show you this video, which is pretty much fantastic. Okay. I'll spare you most of it. I'll take you right to the exciting part.
What a hideous face!
Don't lose hope, Venus. A clam is only a bivalve. Mollusk? Some mollusk! Push yourself away, Robin. I can't, Batman. I can't against the sign. Robin! Robin!
Batman, you're being eaten alive!
Our eyes deceiving us? Has the giant clam really swallowed Robin? With beautiful Venus next on his monstrous menu?
You're never going to know. I'm just going to keep it a mystery for you. Yeah, exactly. Yeah, I'm not sure Robin got out of that one. That's pretty crazy. Okay, so those are bivalves. Did I miss anything? Oh, just one more thing with the bivalves, which is another one I think you're going to be visiting tonight, which is the olive snails down here. They really rely on a siphon sticking out, so basically their strategy is to kind of burrow down, use that muscular foot to sort of burrow down and hide in the sand, but then use that siphon in order to kind of keep part of them up and figuring out where food is. Okay. So gastropods. So this is the biggie. This is a lot. This is the 70,000. So there's no way we can go into a whole lot of details about them. But there are some really cool and interesting things about gastropods. So. There's sort of some subcategories. I don't even know if we're falling into subclasses or classes, but we're going to first talk about what we call the prosobranchs, which means what that means essentially is the gills are in the front of the animal. So the way gastropods get defined is essentially where their gills are. It's not by whether they have a shell or don't have a shell. However, in the prosobranchs, you can see that a lot of those tend to be the ones that have shells. So we're talking about snails. This is a jewel-top snail, just beautiful. Limpets, cowries, abalone, conchs, whelks. So these tend to be ones with shells, though I wouldn't make any sort of generalization, because once you do that, you're in big trouble. Some of the really interesting things about gastropods and about prosobranchs in particular is their asymmetrical growth. So there are two really kind of weird things that happen with these gastropods. One is the way they make their shell is this, it's called helical coiling. So essentially, you know how you see a lot of shells and they're spiral in shape, and they're not exactly just cone-like. They're really spiraled in shape, and you have a really kind of large opening down here. Well, this turns out to be a really stable way to grow. So you see this a lot with this asymmetrical growth happening. What that ends up doing is, obviously creating this kind of a shell, so you see this a lot. And also it creates this opening where a lot of the animal ends up being kind of asymmetrical. So you know how with the chitin we saw that the gills were nice and symmetrical on both sides. Well, that doesn't happen so much with this group, where with this shell growing and causing this sort of asymmetrical growth, you end up having sometimes only one gill, so you don't have gills on both sides. One gill ends up being greatly reduced. The other thing, and this is a little bit different than the shell growth, is a thing called torsion. So some of these animals, torsion happens in the larval phase of this animal. And what happens is, at some point, and it actually can happen within minutes or hours or days, but the whole animal basically turns itself 180 degrees, or at least not the whole animal, the top of the animal turns itself 180 degrees. So rather than having the head at the front and the anus at the back, you end up having an animal where, and this is the interesting part, the anus is above the head. So, and this is kind of, you know, especially for like 6th grade boys, this is a really fun interpretive point, is you're looking at this thing, and I mean, this is a snail, right? How exciting can snails get? But then when you say, get this, you know where the butt of this animal is? It's above its head. I mean, they love that kind of stuff. So that can be really fun. So basically you get everything kind of turning. So there's torsion and helical coiling, which are two different things. Sometimes they get sort of mixed up together, but those are two things that gastropods do that are really interesting and then create this situation where you've got all the kind of good stuff, all the jibbly bits happening over here at the opening. And then the other thing they've got, of course, is this operculum, which is basically a trap door right here, so that all of those good bits can get folded in and then protected by the operculum. So that's one of the ways that they protect, which ends up being some more sophisticated senses. So now with these gastropods, you're starting to get tentacles. The eyes are a little more sophisticated. The sensory organs are just getting a little more complicated. So that's the prosobranchs. Now, if we keep going in the same phyla, there are others that basically the gills are behind. So rather than the gills being in front, they are the more classic shape where the gills are sort of in the back. So again, they're defined by their gills, but these are the ones that tend to have greatly reduced shells or no shell at all. So now we're looking at things like sea slugs, nudibranchs are in this category, sea hares, sea butterflies, sea angels. So these are all snails. When I'm trying to explain that, a lot of times what I'll say is it's like a shell-less snail or a sea slug. So those are sort of common terms that you can use that sort of may help a guest sort of figure out what in the world you're talking about. They are also absolutely beautiful. They're some of the most beautiful animals out there. Some of these different nudibranchs that are just gorgeous. Some of them are very small. You can see right here. Just some really great ones. So what happens here is essentially detorsion. So in the larval phase, this type of animal will start to do that torsion thing. At some point, it will detort, which is not a scientific term, but that's essentially what happens. Is they do the turn, and then they turn back. So that's kind of one of the reasons that they're kind of in the class that they're in. Okay, so we've got the slugs, we've got the marine snails, and then we have the air breathers. So these are the ones essentially that are your land slugs and your land snails. And the main thing that makes them what they are is the presence of, obviously pulmonates, the presence of lungs instead of gills. They are all, by the way, hermaphrodites. And boy, there's some bizarre things happening there. Especially if is anyone a banana slug here? You see it? There we go. So it's a part of the requirement that you have to like learn about all of the crazy physiology of a banana slug. Yeah. Okay. So now we're doing okay on time. Doing okay. Okay. So we're gonna just keep moving forward to the cephalopods. So now here is where we're getting a lot more sophisticated, a lot more organized. And boy, a whole bunch of things start to happen in this world. And again, like I say, we're going to be doing an exhibit on cephalopods next year. So you're going to get all kinds of great stuff during your guide shifts, which I'm going to come in for that because we are doing research here at the aquarium on animals that have never been exhibited before. Yeah, some great stuff. So cephalopod, basically meaning head, foot. So head, foot is basically a reference to the fact that the head pieces are very close to the foot pieces. So in this case, when we talk about mollusks as having a muscular foot, you can see how they are sort of related to snails, because that muscular foot, they are very powerful, muscularly speaking. It's just that in the case of octopus, instead of it being 1 foot, it's become 8 arms with a bunch of sucker discs. Or in either 8 or more arms. So in the case of squid, they have 8 arms, and then they have 2 longer arms that they use to catch food. As a matter of fact, I think I can switch over and use this and show you. Let's see if it works. Oh yeah, okay. So here's an example of Humboldt squid eating. Yeah, so that's a Humboldt squid eating another squid. This is deep sea footage taken by the Monterey Bay Aquarium Research Institute. Nice and slowed down here. So in this case, when they hunt, and they tend to eat a lot more. They don't just eat algae, but those 2 long tentacles go out and grab that food, and then they swim away. Now the question is, can I switch back? Okay, so senses start to get a lot more sophisticated. The eyes, extremely complicated and extremely large. The giant squid, Architeuthis, has the largest eyeball in the animal kingdom. It is about the size of a basketball. It's huge and it's sophisticated. So big eyes. And then all degrees of shell reduction. So in squid, rather than they don't have a shell, but they do have a pen inside of them. It's called a pen, and it's essentially sort of just a little chitinous, cartilaginous remnant of a shell, which helps to maintain their body structure, but is nothing like the kinds of shells that you're seeing in the gastropods. With cuttlefish have what's called a cuttle bone. It's not a true bone, but the same thing. It is a almost like an internal skeleton, though it's not a bone, but it's almost this internal bit that is a remnant of a shell. So there are some degrees of shell reduction. Super advanced nervous system. So this is where now there is an extensive sort of nerve network happening, where they have a brain that is sending messages to the rest of the body. This allows for fast reactions. This allows them to change color, not just changing color, but also changing texture. So just a lot of stuff is happening with their sophisticated senses because of a much more advanced nervous system. And then in terms of their circulatory system, when I was talking about chitins and bivalves, they have a more open system where blood is sort of getting washed all throughout the body. The cephalopod circulatory system is closed, which means that they have vessels. They're moving that blood around very strategically. And then I just showed this. Ammonite is a fossil, a cephalopod fossil. I just thought that picture was awesome. Just incredible to think of how big that is. And then nautilus are also cephalopods, but they do have a shell. So their shell is not as reduced. Nautilus are also very complicated. We do not have any nautilus species here in Monterey, and in the Monterey area, and we don't have them here in Monterey in the aquarium either, but they are good to know. You can definitely check them out a little bit too. Okay, reproduction. So those are just kind of the summary though. So then those are the 4 major categories. So you've got your chitins, pretty simple. There's about 1,000 of them. Your bivalves, those are the 2 shells. There's about 20,000 of them. Your gastropods, there's about 70,000 of them. And your cephalopods, there's 800 to 1,000 of them. Who knows, maybe more. Okay, so then if we were to just look at mollusk reproduction in terms of generalities, really difficult to do because there are so many variations when it comes to their reproduction. But just some things to note, varied in complexity. Most are separate sexes. The hermaphrodites are all land mollusks are hermaphrodites. Most if not all, slugs. So that would be the shell-less snails. A lot of those tend to be hermaphrodites as well. So you have both internal fertilization and external fertilization. External fertilization is when eggs or sperm are either getting released into the water or eggs are getting laid, and then the sperm ends up getting deposited on the eggs outside of the body. But you start to get a lot of internal fertilization too. You get some animals starting to brood the eggs, so a little increase in terms of parental care, so to speak. So fertilized eggs. Then you start to get also multiple sperm donors. So, for example, with some species of octopus, many species of octopus, they can be fertilized by more than one octopus, male octopus. The female will hold on to the sperm, and then she will essentially choose when to fertilize her own eggs. So there ends up being a lot more reproductive control. You start to also see reproductive parts showing up. So for example, and this isn't a great picture of it, but an octopus example would be that on the males, one of the tentacles, and I always forget which one, but I think if you're looking right at the octopus, it's the fourth one to the right or something like that. Anyway, it is modified. It is a modified penis, essentially. So what you can see on it is that there aren't any sucker discs on the very end. So they'll use that to inseminate a female octopus. Lots of varied lifespans too. So in terms of the cephalopods, the strategy is to live a short amount of time. Usually, they're not usually more than 3 to 5 years in terms of their lifespan, and produce a whole lot. And that's definitely the case with squid. Right here, you're seeing what squid do is it's internal fertilization. The male will inject sperm packets into the female, and then the female will lay these squid egg cases. And each egg case will have bunches and bunches of little baby squid in there. So lots of diversity. You could take certainly each class, even each subclass or family, down to species, and you will find differences in all of them that are all really fascinating. The one thing, though, they do all have in common, and this is unique to mollusks, is that there is a larval stage known as a veliger. And this is important to you because, as a guide, you will be working at the plankton lab. What's it called now? Tiny drifters, that's right. And so you will see sometimes baby snails, which are essentially, they're the larval form of the snails, and they're called veligers or veliger snails. Do you guys call them something else? Or is that what you call them? Veligers, yeah. In all but the mollusks, you have this veliger stage, this larval stage in cephalopods. Cephalopods are actually just, when they're born, they're just little baby ones. But with the other mollusks, the veliger stage is basically just sort of a free-swimming larval stage. And so this is some example of some of those pictures. I believe this is a stop that you will be making tonight in your rounds, right? Okay, so you'll be able to see these under the microscope and get an idea of what they're like. So this is actually the second phase in terms of their development, but this is the one that we oftentimes get and we can see, and we have some, I think we have some video clips of it up there too that you can share. So kind of cool. I mean, basically, a lot of people are, I guess, afraid of the plankton lab. Is that a fair assessment? Because they're like, I don't know what I'm looking at, which is fine. You don't have to know what you're looking at. But what's awesome is that these are little baby snails. And so depending on the phase or the stage of development, you can literally start to see even the development of a shell. So what happens here, and this is also where torsion happens. This is the time when, with those gastropods, they'll do that 180-degree turn. And that's kind of interesting. So basically, this is kind of how they look. What happens is that they will have, right in here, they'll have a whole bunch of hairs, little hairs called cilia, which then form into a velum. And a velum means veil, but I like to think of it as sort of an umbrella, because that helps me remember velumbrella. So anyway, that's what I do. And you'll see vellums in some of the other kind of lesser animals that you'll be discussing in the next few weeks. But in the case of the mollusks, they have this vellum, big umbrella with lots of hairs on it, in this larval phase. And then as they settle out, that gets reabsorbed. So then it disappears in the world of mollusks. But that's what you're seeing there is this little swimming umbrella that they use in their larval phase before they tend to settle down. And of course, this is plankton. Now, Lisa made this point. I just want to reiterate it. Plankton is not a species of animal. It is essentially, plankton is all that stuff that's just floating around out there that can't work against the current. So whether it's a small larvae or whether it's a just can't swim against the current jelly, they're all considered plankton and are yummy eats for other animals. All right. We've got 15 minutes. How are you doing? We okay? Maria, how are we doing? Okay, all right. Whew. Okay, so now we're going to get into humans and mollusks. So how do we interact with mollusks? We eat them, yes, we love to eat them. Mainly we eat clams, scallops, mussels, oysters, and abalone. And we eat a significant number of them. Clam is the 10th most popular seafood in the United States. Good to know. Scallops are also a major moneymaker in the United States. They're like number 3 in terms of their value, as is squid. Squid's super high on the list too. But the thing about these bivalves is that most of them are farmed. That's where we get a significant amount of our mollusk seafood is from farming, from aquaculture. And I didn't even realize this before I did this research, is that half of our world seafood production at this point is coming from aquaculture. I didn't even realize it was that high. And of that, about half of that, 25% is mollusk aquaculture, so that's pretty significant. And that's second only to finfish, like tilapia, that kind of thing. So in terms of when we're buying mollusk seafood, mussels are 90% farmed, clams are 90% farmed, and then oysters and scallops, so they're all pretty high. So if we were to look at the seafood watch list in terms of sustainability when it comes to eating these lovely animals, you can see that clams, mussels, oysters, all of those that are farmed are all on the green list. They're all best choices. Farming practices tend to work out really well for these animals, and in some cases, they actually make the water cleaner where they are. Another good thing is they're essentially suspension feeders or filter feeders, so they can kind of just sort of take what's in the water. You don't have to feed them a whole bunch of seafood in order to get them to grow. In terms of good alternatives then, with the world of mollusks, you'll see that all of those are the wild caught. So the major issues that come up with wild caught bivalves in particular are dredging. So in order to get them, you basically have to dredge the sea floor and the seabed to pick them up. Now, dredging is not necessarily considered a very, very sustainable or healthy form of fishing. It's really bad when it's lots of rocks. So not so bad when it comes to dredging on a sandy bed, because the seafloor can tend to recover from that. But that is one major issue. The other major issue is management plans. So unless you have a really good management plan in place, you know how many there are, and you have set limits, it's really tough to be able to say that it's a sustainable product. So those are the two major issues when it comes to wild bivalves. Squid are also a good alternative, which is interesting, because we eat a lot of squid, and so 4% of the world's seafood is the cephalopods, and then squid in particular is very important to California. So it turns out that squid is the #1 fishery in California. 85% of the squid that gets landed in the United States gets landed here in California. But then I have what I call the calamari irony, which is the fact that most of the squid that we eat here in California has been imported. Most of the squid that we catch here gets exported. So if you go down the street and you eat some calamari, chances are it's not going to be from California. So that's sort of the irony, and that's part of the reason that squid is a good alternative instead of being a best choice. That's a management issue. When it comes to squid, the idea of their body plan, be fast growing, get big, and then reproduce a whole bunch, seems like it could manage a high level of fishing pressure. So I feel okay about eating calamari. The only thing is just the wackiness of the fact that I can't necessarily eat calamari from right out there where I see the squid boats. So. Exactly. So it goes over there, yeah. So it's actually cheaper. We export it. It's actually cheaper to export it, have it get kind of processed over in China, or there are a couple of other countries, and then imported back here. And that's actually cheaper.
It's loaded into trucks and pier number 2, goes down to Los Angeles, it's flown to China, it's processed and frozen, and comes right back.
And then comes back here. So it is from here. It just went a really far way to get here. Exactly. So pretty wild. So that's the calamari irony. And of course, who wouldn't want to eat escargot? Me. Yeah, me either. Yeah. There was a woman who was applying for a job here at the aquarium, and I remember her whole story was what she did on the side while she was applying for the job here was she actually had a business where she would collect garden snails, and then she would eat them, and she'd fry them up and eat them. So escargot is one type of snail, but garden snails work for escargot too. So. Okay, mollusks as pests. So another problem when it comes to mollusks and humans is on the left, what you're looking at there are zebra mussels. So these are a freshwater mussel that first appeared in the United States in about 1988 in the Great Lakes. And the thought was, and it just started to sort of take over. So the thought was that what happened was that they came originally from Poland and the Soviet Union area and came over to Canada in ballast water in ships. That ballast water was emptied, and then that started this epidemic of zebra mussels in the Great Lakes. So mollusks can, depending on their life cycle and how many other animals are there, they can be huge threats. They can kind of take over whole ecosystems and whole areas. Millions of dollars get spent trying to figure out how to eradicate, or at the very least mitigate, things like zebra mussels. And of course you have, your typical garden variety snails that also are an issue. The major issue when it comes to, like, say, like your garden pest is basically putting pesticides on these animals and then having high chemicals that around our area, certainly you have a runoff problem. So you're having pesticide issues where that gets out then into our waterways and goes straight out into the ocean and can harm then with the non-point source pollution can harm the oceans. Okay, mollusks as pests and mollusks as pets. So apparently there are these large African snails that have grown in popularity in terms of being a pet. They're just gigantic. And I don't know anyone who has one, and actually it's illegal here in the United States. So they came from Africa. They have started to become pests in Asia and some other areas. And so they are illegal here. But another video that I found that I think is awesome is a snail taking a shower. And so I will let you enjoy this as well. I don't think it sings. I find this super soothing.
Все?
I wonder why they offended me.
Или еще будешь купаться?
You just watched a snail taking a shower. Do you feel dirty all over? Yeah, so I don't know. I like that video. Okay, some other issues when it comes to humans and mollusks, and this was brought up, I researched this a little bit because I know this was brought up with Lisa, which was shellfish allergies. So here's what I learned, it turns out, is crustacean shellfish are the ones, so that's when we're talking about like lobsters and shrimp, that kind of thing. So those are the list on the big 8, which are, they have to be reported if they are in any sort of contaminant. What's the law is the Food and Drug Labeling Act. However, mollusks are not considered a part of that big 8. So they do not have to be listed in terms of the ingredients, or you don't have to be warned when it comes to mollusks. But likely if you have a sensitivity to crustacean shellfish, you will have a sensitivity to mollusk shellfish as well. And I am not a doctor. So, you know. The other thing, though, that does happen is paralytic shellfish poisoning, or red tide, or the other thing that it's called is domoic acid poisoning. So this is from harmful algal blooms. This is different than like a shellfish allergy. And this occurs in bivalves. So this is where, you know, the rule is, you know, when can you collect mussels, that kind of thing. So that is something that happens. And, you know, I always wondered about that. You know, have you guys heard the kind of, it's a wives' tale basically, but it's like, don't collect mussels in any months ending in the letter R. Right. Okay, so I looked that up to find out if that was a myth. So, and I looked that up at the, whatever that is, that link. And basically, it's not true. The quarantine is between May and October because that is the most likely time that you're going to have harmful algal blooms, essentially that will infect or that will make the mollusks not a good idea to eat. So that's shellfish poisoning. I'm still not a doctor. Another thing I didn't know about, snail fever, which affects a whole bunch of people in island nations and developing countries. Over 230 million people are affected by snail fever. It ranks second to malaria in terms of public health importance, and yet I didn't know anything about it because that's what you call a first world problem. That's a third world problem. But basically what that is it is a roundworm parasite, and snails are the intermediary host. So what happens is if kids are playing in contaminated water, they get this, causes all sorts of problems. So huge problem there. That's another thing that happens. And then of course shells. There's all sorts of things with shells and humans. Shells are considered curios. Shells at one time were used as money exchange. Shells are used for musical instruments. Shells have been used as jewelry. The only thing about shells, and some people feel really strongly about this, is that, well, two problems. One is if you go to a shell shop and you buy some really exotic shells, chances are good that it wasn't just a shell that washed up on the beach. The animal was killed in the process of getting the shells to sell in the curio trade. So we discourage that. You know, I had a shell collection when I was a kid. That was when I was on the beach and I collected my own shells. But do be aware of the fact that when you're purchasing shells at like a trade shop from all over the world, sometimes those animals are killed just for their shell and then sold. The other thing is that shells often become homes for other animals like the hermit crabs. So when you do take shells off the beach, you're also taking a potential home for other animals. So those are a couple of other issues. I am almost out of time. We have like 2 minutes. And so some of the wackier members of the mollusk family, basically we have this wonderful sister institution, the Monterey Bay Aquarium Research Institute, and they have, of course, given us an amazing amount of video footage of things that they have seen out there. And so with just the little bit of time remaining, I just wanted to show you a few of course, some of the fantastic things that come from the deep sea when it comes to mollusks. A lot of really great cephalopods, certainly. Does anyone know what this one is? Very good, yes. Okay, so vampire squid, or scientific name, Vampiroteuthis infernalis, meaning vampire squid from hell. Which is awesome. So this is a great one. And this is a really interesting one too, because they call this a living fossil. So this one, as a cephalopod, essentially, if you were to say, well, squids are like this and octopus are like this thing sort of predates the development of both squid and octopus. That's why they call it a living fossil, is because it has elements of both squid and octopus. Some of the cool things it can do is essentially turn itself inside out with that vampire-like cape. And so it wraps itself up in a little ball. Scientists call that the pineapple pose. Another thing, of course, that's really great about it is it bioluminesces. Sorry, Maria. Parts of it glow in the dark, and you have to have a special camera to be able to see this, but the tips will glow in the dark. And then these two things right here up on the top, they look like eyes, but they're not. They're just glow-in-the-dark spots that make it look nice and scary out there. So it's glowing. Let's see, what else? There's some great ones. This is a great one. That's called the piglet squid. Isn't it cute? I know. Or this one. Yeah, the cockatoo squid. Yeah, another great one. So, of course, you can see, if you go into the deep sea, then all bets are off. You have animals that are no color at all. They're completely clear in color, so you can see their insides. You start to wonder about inking, that kind of thing. So why ink if you're down there in the dark? So then you just have a whole host of other animals you can start to explore, and it just becomes all that much more fascinating. Oh, there it went. This is kind of a cool one here, the cockeyed squid. Check out these eyes. So there's one eye right there. It's true, there's a siphon. Lovely. And then there's the other eye right there. Yeah, so it has one huge eye and one greatly reduced eye. It basically swims along, and it's down there pretty deep. So it swims along, and that great big eye is facing upward, getting as much light as it possibly can from up above, whereas that other eye is super reduced, looking down into the darkness. Another really awesome thing here, this is a black-eyed squid, but what you're seeing here is, in this case, with this squid, it's actually holding on to its eggs. So that is a brood sac right there of baby squid, and they're starting to hatch. So you see some things kind of floating around in there. So little baby squid hatching from that brood sac. So there's an example of brooding happening down in the deep sea. If there's no place to lay your eggs, there goes. Hello, little baby. Are you so cute? You're the cutest thing ever. Are you a good boy? Yes, you are. Okay, and I will leave you with this one here, which is other cute babies. We're looking at basically juvenile red octopus there. So again, down there in the deep, where are you going to hide? Well, they seem to be gathering around this really large jellyfish. I'm out of time. All right, well, hey, thanks, everyone. That was a lot. That's a lot of stuff, huh? Yeah, that one's a gorgeous one, too. All right, see you at 7:30.